In this video, we're going to talk about the fifth and sixth example for discrete probability. The fifth one, a life insurance companies will sell a $200,000 one-year term life insurance policy to an individual in a particular risk group of a premium of $1 of 195. Find the expected value to the company of a single policy if a person in this risk group has a 99.97% chance of surviving 1 year. Now, if we're going to proceed this solution, let X denote the net gain to the company from the sale of one such policy. There are two probabilities. The first one is the insured person lives the whole year or the insured person dies before the year is up. Applying the income minus outgo principle, in the former case, the value of X now is 195 minus 0. In the latter case, it is 195 minus 200,000. This gives us negative $199,805. Since the probability in the first case is 0.9997, and in the second case, okay, remember that the sum of all probabilities is equal to 1. To get now the second case, we're going to subtract the first probability as 1 minus 0.9997. This gives us 0.0003. The next part of the solution is to build x and p of x. Okay? To illustrate it, this gives us x. Okay? For the x now, we're going to put the values of the money. If x is at $195, the probability is 0.9997. On the other hand, if X now is equal to the difference between the premium, okay, and the premium sold at 195 minus 200,000, this gives us negative 199,805 with each respective probability as 0.0003. Now, if we're going to solve for the required or asked on this problem at expected value, E of x is equal to mu, which is also equal to the summation of the product of each individual element of x and their respective p of x probability. Okay. Substituting now the following values, this gives us 195 times 0.9997 plus negative, okay, $199,805 times the probability of occurrence at 0.0003. This gives us the expected value at $135. Now let's proceed with the sixth example. A traffic engineer is interested in the number of vehicles reaching a particular crossroads. During periods of relatively low traffic flow, the engineer finds that the number of vehicles of X reaching the crossroads per minute is governed by the probability distribution table. Okay, we have this one. If X now, okay, the number of vehicles at X, which is 0, 1, 2, 3, and 4, the probability of occurrence as P of X discrete X would be equal to X at 0.3740, 0.3941, 0.1942, and 0.0443, and 0.0144. Now we're going to calculate the expected value. EX or the mu, and then the variance, and lastly, the standard deviation of discrete variable x. If we're going to proceed now with the solution, we have to establish your x on the column, leftmost column. And then for the second column, we're going to square whatever values we got for x or given values for x. Okay? For 0 squared, that gives us 0. 1 squared, 1. 2 squared, 4. 3 squared as 9, and 4 squared at 16. The next column, okay, we're going to copy whatever given probabilities we had for P of or probability of discrete x would be equal to x. For the 0, we have 0.37 for 1, 0.39 for x at 2. A, we are given with 0.19, and at x at 3 as 0.04, and x at 4 at 0.01. Okay. To solve now for the f of x, how are we going to do it? Okay. F of x now is equal to 1. Okay. We're going to solve it now. This gives us f of x at 0.37, 0.76 for 0.39, 0.95 for 0.19, 0.99 for 0.04, and lastly, 1. To solve now for the expected value, this gives us the summation of x multiplied with the probability of discrete variable x equal to x. Substituting now the following values, remember that this formula, okay, we have to multiply your x or your 0, I mean your x times your value at p x is equal to x. For the first one is 0 times 0.37 plus 1 times 0.39 plus 2 times 0.19 plus 3 times 0.04, and lastly 4 plus 4 times 0.01. This gives us a value of 0.93. Solving now for variance, okay? Variance in terms of v of x or sigma squared, okay? We have a new established equation as this one. The difference between e times x squared minus e of x quantity squared. Okay. To solve this one, e of x squared, we have this formula as the summation of x squared multiplied with their respective probability. And then you're going to subtract it with your value here, with the square of your value here, okay? Square of e of x. Now, if we're going to solve this for e multiplied with x squared, okay, the summation now gives us 0 times 0.37 plus 1 squared times 0.39 plus 2 squared, which is 4 multiplied with 0.19 plus 3 squared. So that is 9 times 0.04, and then plus 4 squared times 0.01. Subtract it with e of x at 0.93 squared. This gives us for variance at 0.8051. And for standard deviation, we're just going to get the square roots of your variance v of x or the square root of sigma squared. So this gives us the square root of v of x at 0.897 or almost zero point 0.9. Now that ends my presentation for problems 5 and 6 regarding discrete probability.